Welcome back to our series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 1446, that is consecutive characters. Okay, so before starting a question, today I have something special for you, that is some brain teasers for you. So to know that or to learn about that brain teasers, keep watching video until you find them. So let us start our question now. So the question says the power of a string is the maximum length of non-empty substring that contains only one unique character. So the question is saying that if we have to calculate the power of any string, how we can calculate is that the power of the string would be the longest or the maximum length of non-empty substring. Non-empty means that it couldn't be like no characters in them. It should have at least one character in them that contains only one unique character. That is like in this question, in the example one, LeetCode, in the character string LeetCode, we have like two consecutive e's, and there are none other character which are greater than two length and in consecutive manner. Like in this second example, we have two consecutive b's but three consecutive c's. So the value of c's, that is the strength of our string, is no longer a 2, it's become 3. But when we move forward and look at these, they are 4 in number, so it would become now 4. And when we proceed further, we see that e's are 5. So now our final strength of power of a string is like 5, because none other character exceed the 5 length in consecutive manner. So we have given some constraint that our string length should be always greater than 1 and less than 500, and s consists of only lowercase English letter, so that we don't have to care about like other special characters or numbers. So let us explain our solution in little bit more detail and see how could we solve this question. So suppose this is our example string bookkeeper, and we have to calculate the power of this string. So visually in our with our eyes we can see that it has two consecutive O, then two consecutive E's, then K's, then two consecutive E's, and there are not the character that are more than size 2, that are repeated than two more than two times in consecutive manner, though there are three e's, but they are not in consecutive manner, so its power should be like 2. So how we are going to solve this question? The approach is simple. Initially, what we are going to do is that uh, we are taking our first element or first character as the initial character of our string, that is this one. And what we are going to do is initially because our string is at least one length, so it couldn't be, our power couldn't be 0, so we are taking three variables, and one stores character, the current character of the string, to match with the previous or the other characters, and the second variable stores the temporary power of the string until the character changes, and the third, which stores the maximum power up till what we have exceeded, or what we have like proceeded, what we have gone through. So initially, for this example, initially our character would be b, that is our first character of our string, and our temporary power would be 1, that is power b repeats 1 times up till now, and our permanent power, or our like largest power, is also 1, because this is the largest temporary power up till now. So when we move further, we found that we didn't find the same element. So we check for the element if it is same with the previous one, and if it is not, like how could we check the value stored in the b, if it is same with the next character, then what we'll do is, but in this case we didn't find the same, so what we do is update our character from b to o, and our powers are still 1 and 1 because we didn't find the consecutive character. And when we move for the next character, we found it as same as our previous character, that is ch. So what we do is that we will increment our powers, that is temporary power will become now 2, and our permanent will also become 2, because it is the largest temporary power up till now. But as we move further, we found the character changes, so our character will now no longer be O and it will become K, and our temporary power will reduce from 2 to 1 because now K is the first time appears in the string, and we didn't see the character from this character previously. So but our permanent power, or the largest power, will remain 2 because this power is the final power of the string, so it wouldn't be reduced, it can only be increased. So it is this kind of character. And when we move further, we found our next character is also same, so our K will remain same, and our temporary power will now become 2, and our permanent power will remain same too. And as we keep on moving, we will find that our characters and temporary power will keep on changing, but our permanent power will no longer change, and it will remain 2. So how could we code this idea? So let's get into our coding window and see how could we do this. So initially we have three characters, that is two integers. Integer temporary power, that is pow, equals, initially it is 1, and our next character is power, that is initially is also 1. Okay, and we have other variable, that is character char ch, and it holds, initially it holds the 0th index character, that is first character of the string, so it would be like s dot caret, and I, what is, I don't know, we didn't have any variable I, s dot caret 0. Oh, okay, now we go on iterating over whole this string to, in order to find the same situation, and in order to calculate the strength or the power of the string. Okay, so for, and we are here starting our variable from 1, not 0, because we have already calculated the power of 0, and it is still stored in our character ch. Okay, then I is less than s dot length. So I will like move from second character to up to last character, and then I plus plus each time. Okay, so in this thing, what we do is we check if s dot caret I, and s dot caret I, if it is equals to our previous character that is stored in our character, then we have no problem. We have to simply increment our power, that is our power will increment and nothing happens. But if this is not the case, that is if we are in else part, what I'm doing else, that means the character is not same as previous, then we have to update our character, that is our ch would now become, ch would be s dot caret I, and now our pow, temporarily pow variable, will be reduced to 1 because this character appears first time in consecutive manner. And each time we will check if our power, that is if our power variable will be greater than if power, then simply what we do is we'll say our power equals to power, so that our power, if the power variable exceeds the power, then our power would be the greater one, but if it is not, then our power will remain the same. And now we can return our power. Return power. Let me check if it works or not. So yeah, it did work. Let me try some other examples so that we can confirm that it is not meant for only one question. So let's see if it works or not. Now let's submit our code to see the optimality or the time and space complexity. Though we know we are using only one loop, so it's of n, it is faster than other examples, but I don't know why. So now it's time for Brain Teaser. So in the Brain Teaser column, we have put LeetCode question number 292. That isn't basically a question. It is just simply a brain teaser. You have to just use your brain. No knowledge of like Python, Java, or anything is required. No programming knowledge is required, but only your brain is required. So let us read the question first. So you are playing the following name game with your friend. Okay, what the game is? Initially, there is a heap of stones on the table. Okay, there are like stones placed on in heap on this on some table. You and your friends will alternate taking turns, and you go first. So okay, we are going to take alternate turns, and first chance or first move I will make or you will make. Okay, so on each turn, the person whose turn it will be remove 1 to 3 stones from the heap. Okay, so in each turn we could like remove 1, 2 or 3 stones at a time. Like we have choices, we can remove either 1 stone or 2 stones or 3 stones. The one who removes the last stone is the winner. Okay, so the person who removes the last stone will be the winner. Given n the number of stones in the heap, return true if you can win the game, assuming both of you and your friends play optimally, otherwise return false. So we have to return like true if there are chances both you and your player are playing optimally, they have the same level of intelligence and they are giving at most of them, and you have to return if you can win the game, you have to return true, and if you can't win the game you have to return false because both of the players are optimal. So in the example one we have 4 stones, so it will be false. How it will be false, let us see in the like our graphical solution. So suppose this is the situation, but in this case if we suppose have only 4 stones, then we have to lose, as our example says. How we'll lose, let me show you. Okay, so let me remove these stones. Control X. Okay, so this is the situation initially. So in this situation you'll always have to lose the game. How you'll have to lose the game? Because the one who removes the last stone will be the winner. So if it's your turn, so you have to always lose the game. So suppose you remove 1 stone. Okay, so you remove 1 stone. Now it's your friend's turn. He can remove all the 3 stones, and the last stone is removed by your friend. But suppose if you remove 2 stones, then too he has choice to remove 2 stones to win the game. And even if you remove all 3 stones, then too the last stone will be removed by your friends because both of you are playing optimally. So the example what we have before, let me show you that how can you win, is that suppose we have like 6 stones, we add these 2 stones again, and now you can win. Now you have to win if both of your friend and you are playing optimally. Now how you can win is that even if you in this situation, suppose you remove 1 stone, okay, 1 or 2 stone, whatever, you remove 1 stone. Now what your friend could do, you have to remove like 2 stones if you remove 2 stones, and now your friend enters the same situation before what you have been when you have 4 stones. Now turn is your friend's turn, so he can remove either 1, 2 or 3 stones. In whatever case, whatever he removes, the last stone will be left for you to remove. So in this situation you'll win. So the catch is here that if the stones are in the multiple of 4s, then you are the one going to lose. But if the stones are not in the multiple of 4s, then you have the chance to win. Suppose we add some extra stones, like we made them 8 stones, then they are in the multiple of 4s. Now whatever the case will be, you have to lose the game because they are multiple of 4s. Because how we come to the solution that the multiple of 4 would lose, because you can remove at most 3 stones at a time. So now in this situation, whatever you will remove, either 1, 2 or 3 stones, you have to lose. Suppose you remove 1 stone. Initially you remove 1 stone, then what your friend could do is that he will remove 3 stones. In order, then the situation enters the same situation that you are again on the 4 stones. The situation you have previously occurred, that is, you have previously met in the situation of 4 stones, you have to lose. Whoever turns is this in the situation of 4 stones, he will lose. And suppose whatever you do, Like suppose you didn't remove one, you remove two stones at a time, then your friend will also remove two stones to make you lose. And suppose you remove three stones and your friend will now remove only one stone, the situation will again and again become the same. So whatever, if the stones are in multiple of 4, you are the one going to lose. So the solution is quite easier. That is, you wouldn't expect it to be only one line of code. It is return that return return and mod 4 if it is not equals to 0. Yeah, if it is equals to 0, you are like going to lose. And yeah, if it is not equals to 0, you are going to win. So and mod for if not equals to 0, then you are going to win. Then you have to return true, otherwise it's false. Let me check if it works or not. It did work. Let me submit our code to see if it is optimal or not, because it's nothing. It's just a simple one line of 100% faster. So this is our brain teaser. Keep watching, and if you have better approach, you can comment down below for this one too. And thanks for watching.